I've got a new system for discharging my batteries set up on the top of the shed up here. Today I'm going to test it for the first time doing a high discharge battery test. If you want to know the details on these batteries, then have a look at earlier videos, but I'll quickly run through in a summary. These batteries, they came from Recycle Place. They've got Hyundai and Kia written on them, so I assume they're out of electric cars. They're in two sections, and so the left section is completely separate from the right section electrically, and so you've got your negative and positive terminals on each side. Each side has 6 NMC lithium cells in series. Sorry, there are 12 cells, 6 in series and 2 in parallel. So there's 24 cells altogether, roughly around 5 kilowatt hours worth of power in this thing. And so each side makes around 20 volts or so, what is it? It gets up to 25 volts when it's full each side. And so you can put them in parallel or you can put them in series, but in multiples of 25. So with these cells, I don't know what they are. They have no markings on them, but I have had experience with LG cells before. This is a data sheet for an LG E63 cell, and every test that I've done has matched the data in this data sheet, and so I'm sort of assuming that they are probably something like this. They might be a bit different capacity, but something like this. Possibly slightly lower than the 63 amp hour version on this data sheet. And so what I'm doing today is the discharge resistance test. And so what I'm looking to calculate is the internal resistance of the battery cells. And the reason I'm doing this is, since these are unknown cells, they could have been damaged, could be some problem with them. I want to do a couple of tests just to see what happens. And the discharge test is a good one. It puts the battery under a bit of stress, puts each cell under a little bit of stress, and we'll see if they react, if they react different to the other cells. So if there's one cell that goes higher or lower voltage than the other ones during this discharge test, then there's probably some problem with that, and maybe I shouldn't use that battery module. Okay, so what we do is we start off with a particular state of charge. This battery that I'm going to test today is at 100% state of charge. I've charged it all the way up. And this test says to set the maximum current to 175 amps. I'm not going to be able to get to 175 amps per cell. The cells in the modules are 2 in parallel, and I calculated I'm going to do roughly 200 amps, and so I'll be getting something like 100 amps per cell. So not at 175, but I'm not sure that this data here is for the same cells that I've got, and I couldn't get to 175 per cell anyway. Okay, and so if you look at this table, what it says is start at state of charge of 100%, test current at 175 amps for either 10 seconds or 30 seconds. I'm going to do a 30-second test, and so in that case, you do this little calculation here. You do the start voltage and then the minimum voltage that the cell got to during the 30 seconds of 175 amps. And so the difference between those voltages divided by the test current gives you this resistance here. And so we'll see what we can do with our battery. So let's run through the setup here. First we have our battery under test. They're 30 kilograms, so they're reasonably annoying to move around. And I'd like to test it outdoors so that if it does catch on fire or anything silly like that, then it's not going to do too much damage. So inside a metal wheelbarrow seems like a reasonable idea. I've got it set up to test one side of the battery module. I'll do it one at once. That means I've only got 2 cells in parallel. To do this discharge test, I previously did some experiments where I worked with fencing wire. And so the fencing wire that I've used in the fence all around the farm here has a specific resistance, and so I just put the current through that wire. So literally put a wire from here to here, and the battery will just discharge through that. Now, to get the right amount of current, I need to get the right length of wire. That's how control how much current I'm going to discharge out of these batteries. So in the experiments that I did last time, I found that 10 meters of length gives me about 50 amps of current. Now this time I want to do 200 amps. I've decided 200 amps seems like a feasible amount of power, which means I want 4 lengths of 10 meters. And so I've put some up here. So on the roof of this shed, I've used electric fence insulators, ceramic ones, so they should stand up to heat. So that the 10 meters did get reasonably warm. And so I put it up here on the metal shed where it doesn't matter if it gets hot. It's on ceramic insulators. So hopefully this will be good. And so what we've done is I've done 4 lengths. So I've got 40 meters of wire here, and I've run it round and I've connected on up the top and down the bottom here in a manner that means that I can run each of these 4 wires in parallel. And so I connect here. These are connected together. So this is the ends of 4 wires, and this is the other ends of the 4 wires. Now the other end is up there. And so that's the other end of the 4 wires. So basically those are connected together. So down this end, those 2 big cables are connected together, and that means we can get 4 parallel wires of 10 meters each. Hopefully get 50 amps for each 10 meters, so that's 200 amps altogether. Now I've got the battery management system on this and a contactor to turn things off if anything goes wrong. So the battery management system will use that electronics on the ends of the battery there to monitor each cell voltage. If the cell voltage goes too low, it will turn off. If a temperature gets too hot, it will turn off. I'm only doing this for 30 seconds, so it's probably not enough time for a temperature to go too hot anyway. I'll also be monitoring with the computer. I'll be monitoring I'll be recording each cell voltage sort of once a second or so. And so that's how I will tell the minimum voltage of each cell. So what I want to know is the resting voltage and then the lowest voltage that any cell got to within that pack. And yeah, if one of those voltages, if one of those cells got to a lower voltage than the rest of them, then I might start to be concerned. So let's connect this battery up. We have power and we have comms. Let's do comms first. So this is for the battery management system. And so the electronics on the cells there needs to connect and talk to the main master unit back here. So that's connected, and then we can connect the power. These big Anderson connectors are annoying. Okay, there was a click. So what we've done by putting this battery on here is we have powered our battery management system, and that now has control over this contactor. So what we want to do is connect the batteries, the battery to the test thing up here. I need to come up for a name for it, don't I? The fencing wire. So let's go get some cables for that. So I've connected these 2 wires here into the system here. Battery's disconnected for the moment, but what this will allow us to do is the battery positive and negative comes through here, Our positive is on here and is connected through to the one end of the wires. The negative of the battery is connected here and goes through into this system here. So first through an emergency stop, through an isolation switch, so I've got that isolated at the moment, through a fuse, and then into this contactor. This contactor is what's controlled by the BMS, and then through to this one is the wire. So we can connect the wires to the battery through these two switches here, the contactor and the manual switch here. So at the moment I've got disconnected, so I should be able to connect the battery back up now, and it will power the BMS and everything, but won't do anything else. Now I've got my current meter here. I'll just use this to check. So I'll turn this on to amps and DC, and so we've got nothing running there, or 1 amp. That shows you how accurate it is. We'll connect up the battery and see what it does. So when that BMS was first powered, it turned the contactor off. It must have come on to start with. I heard it click twice. So it must have come on and then turned off while it was starting up, and then it turned it back on again. So it thinks everything's happy now. The contactor is on, but I don't have my isolator on here. So let's just see what the BMS is telling us. We have total voltage of 24.7. Highest cell is 4.14 volts. Lowest cell is 4.12 volts. So they're all sitting nicely balanced within a couple of, what's that, milliamps, within a few milliamps of each other anyway. A few millivolts of each other. Oh, and the other information on here is that the highest cell, the cell number with the highest voltage is 5, and with the lowest voltage is, well, there was 10 and there was 1, so they've got the same voltage there. On the computer, if I open this, then we should get some data. There we go. And so we have each line of this, we've got the time, and then V for voltage, and then a list of the current cell voltages there. So 4.12 is very common, and in fact they all look like they're 4.12 most of the time. We had a slightly different one on there, didn't we? 4.12 to 4.14 it says on the screen. So is there a 4.14 there somewhere? There should be. Oh, there it is in the middle. It did say it was cell 5, didn't it? So cell 1, 2, 3, 4, 5 is 4.14. Oh, and here was a row with T for temperature. So it mostly does V for volts and occasionally does a T for temperature. Okay, see our cell voltages, cell temperatures there are all between, what is that, 14 and 19. So one side is in the sun and one side hasn't warmed up yet. So we have our computer recording. We have everything set up. Positive. Yeah, everything looks right to me. We've got our still 0 amps here. Where are we? Almost 0 amps. So if I pull this button out for 30 seconds, we should be able to do our 30-second test. Something I forgot to mention is I've got I don't know how hot this wire is going to get. I've got a thermistor on it there, and this here, temperature gun, and if I press this button here, that's the temperature of the wire. Okay, so let's pull this out, de-isolate this for 30 seconds. I've got my clock ticking down there. Ah, of course. It's above 60 amps. There we go. Oh, so we haven't got to 200, I don't think. It'll be interesting to see actually with the the next one, if I can catch it right at the start, as it's warming up, the resistance going higher, and so the current's going down. There's 30 seconds. Okay. Okay, this is back to our computer here. We can see the values that were recorded during our test. So we did a 30-second test. So if we scroll down here, we should find where it's gone. Here we go. So this is immediately, you can see here, it's nicely at 4.12, 4.14, and then suddenly it's gone down to 3.99, 3.98. So this is where it's happened here. Now we've got 12 readings here, but we only did half of the battery module, and so we're only looking at these 6 here. We'll need to do the other half later. So what we're looking for is the lowest one of these to put into our test. So I might copy this and put it into a spreadsheet. Okay, so our temperatures were fine. There we go. Good, so this highlights the lower ones. Let's see, so 3.92, this one went the lowest. This one stayed the highest, but there's not very much difference between them. We've got the worst and we've got the best. In here I've got a formula to put the minimum and the maximum, so that's the worst and the best. Let me just check which I'm on. So I'm on the right side, so I'm on this one here. So if I look at our worst cell min, okay, all started at 4.12, and so that means that here we had 4.12 was the resting volts for both the best one and the worst one. The current, what did it get up to? It wasn't quite 200, was it? I didn't look. I didn't know, so I didn't have the meter quite turned on, did I? It was something like 175, so let's put 175. And then the cell minimum volts, the worst cell volts, was 3.92. Oh yeah, lots of them got to 3.92. And the best one was 3.94. So 3.92 and 3.94. Test length was 30 seconds. Okay. And so we have the worst internal resistance was 2.29 milliohms and the best was 2.06. So if you have a look at our sheet here, on this one here, oh yeah, so we're significantly worse than these. That's interesting, even though we didn't have as high a current. So it'll be interesting to see how this compares with other batteries that I do, whether any of them are any better or worse. So 1.75 for 30 seconds, whereas this was 2.29. Okay, so to do the other side, I'll need to disconnect some things. So now I've got the other side connected. We're still monitoring all of the 12 cells, and so we can see now our highest is 4.14. We've gone down to 4.10 now because we had this discharge test discharged half of the cells for 30 seconds. I do want to keep the cells all very similar to each other, and so I'm going to do the other side for exactly 30 seconds as well. What are we doing this time? So let's turn this onto the right amount this time again. This time, there's two things I didn't do last time. One was to check the maximum current. And so the maximum current should be the same for each side, but I didn't check last time, so I can't really tell, but I'll see what it is this time and probably use that value for the current for the other time as well. And the other thing I didn't do is the temperature. So I would like to know the temperature. I really need to do that during the 30 seconds. So I think we're all set up again now. We've got it connected. It's monitoring fine. Yep, everything's ready to go. Okay. Oh yeah, we got just to 200, or almost to 200. Let's see what the temperature is. Oh, not very hot at all. Okay, only up to about 50 or so. Here's our time to go now. Good. Good. So for this one, the minimum was 3.94, maximum was 3.97. So again, there's not a lot in it. And that was the highest one there. So the one with the highest voltage at the end had 4.12, and the one with the lowest voltage at the end, all of these, also had 4.12. So 4.14, that was the only one that was the highest at the start, but it wasn't highest or lowest at the end, which is interesting. Anyway, 4.12 for the start voltage. Back to here, and this is here, isn't it? So this is the left, yep. So 4.12, 4.12. Oh, so the current this time was, yeah, just about 200, wasn't it? So 198 or something. And our lowest was 3.94 and 3.97. 3.94, 3.97. Test length was 30 seconds. Okay, so we've now got this side, we've got 1.82, 1.52, and compared to here, oh, this is very much more similar to this actually, isn't it? So yeah, that would be presumably because of the current. Where is the current? So there, if I put that in as 198 as well, which I reckon it probably was, we get 2.8. Okay, so the one side is slightly different to the other side. That could be the current might have been different because the temperature was still a bit warmer. It's warming up, and it might have still been a bit warm for another. So, for instance, if the current on that first test was a bit higher, say 205, what would that give us? Yeah, okay, yeah. So I don't actually know because I missed out on that current on that first test. I could do it again, but I don't think I'll bother because those, I think, are near enough to each other. I don't see a large difference between the worst and the best out of this battery, but it will be interesting to compare as I go through and do more of them. This is the first one that I'm testing. And so, yeah, the idea of this test is to test a whole lot of these batteries and see which ones are the best and the worst and so on. I'll be able to get a better idea then. So the next thing that I want to do with this battery is to discharge it down to 80%. It's currently at 100%. I finished all the tests I want to do on it, and I want to store it. So let's store it at about 80% capacity, better for the cells. Now looking at the data sheet, 80% is around 3.9 volts. So what I've done is I've reconfigured my battery management system so that it will turn this off when it gets down to, when one of the cells gets down to 3.9 volts. So I'm going to use this system to discharge the batteries. Now, I don't want to go at 200 amps this time. I decided 50 amps is probably a good figure to discharge them, and that's both in parallel, which means 25 amps on each side. So I've reconfigured my discharge system up here. So the the orange connections up there now are not used, so the current just goes straight through those now. And yeah, so down here I've disconnected it here altogether. And so if we just concentrate on this side, what this means is there's two wires here running in parallel, and they go up and around and back again and back down to here. And this is the other end of those two wires. And so what we've got here is two wires in parallel. Each of these wires is 20 meters. 10 meters gives you 50 amps, but it's too hot. And so I don't want to run it just through 10 meters for however long it is that I've got to run this to discharge it. So instead I've gone 20 meters, which is 25 amps, but two of them in parallel. So hopefully this will be about 50 amps. I think everything's set up. So we're ready to do this. We're not timing it this time. $56 amps. It is falling. I'd hoped it wouldn't fall much. I'd hoped it wouldn't get too hot. But it is falling a bit. And so we were starting out before we were at 4.11 volts. And so we're falling a bit now. The temperature of the wire is up around 44. Oh, that's interesting. That's similar to what it was when it was under 200 amps. Yeah, it's definitely warm. So after a little while, this current has settled down to a bit under 50. I'm quite happy with that amount of current. That seems good. Still decreasing slowly, isn't it? And the temperature of the cells, and so the way you read this is it's 25 degrees is the highest one and 20 degrees is the lowest one. I've just put a sun hat on there, sun hat / rain hat, because who knows what the weather's going to do. And let's have a look at the temperature of the wire. So the temperature of that thermocouple there. Yeah, so it is quite warm. It's taken, that was interesting. With the 200 amp test, it only got up to about 50 or so degrees, but this has been sitting here for a lot longer. Where that is, it's about 90 degrees. Where that is, I've covered it up with tape. Out here, it's probably not quite as warm because it can immediately dissipate that heat to the air, but I'm not about to touch it. I will touch these ones. It's been about 40 minutes. I worked out that discharging from 100 to 80 would have taken about, oh, there we go, turned off now, about 50 minutes. This has just taken 40 or so. It's just switched off as soon as one cell got to 3.90, and now it's turned itself off. It's turned the connection off between the battery and the wire, which means suddenly it's not under load anymore, and so we've gone back up to 3.92, 3.93. It's rebounded to that voltage. So the current, I was going to take a video of the current, but it was just 47, something like that. And the temperature was around 90 degrees. So let's see what it says now. Yeah, it's very quickly coming down, isn't it? What this means is that I'll do that same voltage for all of these battery modules. And so all of the cells in all of the modules should be almost the same voltage, which means that I can connect them together in parallel or series or whatever, and they'll be reasonably balanced.